Hello sa inyo lahat dyan. Ito yung una kong video para sa subject na hydraulics. And hindi ko naman pahabain yung aking introduction. So simulan na natin dito sa um, fundamentals of flow. Okay. So let's talk about flow rate. So when we say flow rate, so it can be the volume flow rate, mass flow rate, and weight flow rate. So yung pinaka-common na flow rate is yung volume flow rate. And ang symbol natin dito is yung Q. Okay? Or ito tinatawag nating discharge. Okay? So when we say discharge, so commonly that is volume flow rate, and Q is the volume amount of liquid in terms of volume that passes through a point per unit time. Okay? So normally per second. So unit natin dito common is cubic meter per second or liter per second kapag mas maliit lang yung volume flow rate, or can also be cubic foot per second. Okay? While yung mass flow rate, iba-iba naman ang symbol na ginagamit dito. So, para mas common kasi nakikita ko yung M with a dot. So, yung mass flow rate from the word itself, mass. So, this is the amount of liquid in terms of its mass that passes through a point per unit time. Okay? So, ang unit natin dito normally is in kilogram per second, or pwede rin slugs per second. English units. And yung ating weight flow rate, so alam na natin na, no? So, weight, so that is weight over time. Okay? So, ilang Newton ang dumadaan sa isang point per unit time. So, ano-ano unit ng weight can be kilonewton per second, or newton per second, or pounds per second. Okay? Ano naman ang relationship nung itong tatlo na to? Okay? So, in terms of their formulas. So, in fluid mechanics, ano ba ang madalas na binibigay na property ng fluids? So, madalas, we were given the specific gravity, the density, or the unit weight. Okay? And alam natin na yung unit weight is, actually, that's the density times the gravity. Okay? And for us to solve for the mass, by the way, so density is mass over volume, unit weight is weight over volume. So, lagyan ko ng ganitong symbol yung volume para hindi tayo malito dun sa velocity. Okay? So, solving for mass from this equation, so that is the density times the volume. While solving for weight, so we will have the unit weight times the volume. Okay? So if we substitute this dito sa mass flow rate and sa weight flow rate, so makikita natin dito na yung mass flow rate is equal to the density times the volume, okay? Then over time. And volume over time is, diba? So that is discharge. So this is discharge Q. So solving for the mass flow rate, so this is simply equal to the discharge times the density. While dito naman sa weight flow rate, so weight is equal to the unit weight times the volume. Okay, so this is the weight. Okay, pinalitan natin ito. Then over time. Okay, and same lang nung sa mass flow rate. So we have volume over time, which is equal to the discharge. So solving for the weight flow rate, if we have the discharge Q, so multiply lang natin ng unit weight. Okay? And going back dito sa discharge Q, so diba meron tayong volume over time. So how do we solve yung volume? Okay? So let's say meron tayong pipe dito. Tapos, of course, meron tayong flow. So let's say ito yung ating reference point. Then, let's say meron tayo ditong cross-sectional area. Okay. And assuming na so maraming particles yan, of course, ng liquid, assuming na they will all travel at the same velocity. Okay. Then after a given time, so these particles will travel a distance, L. And if we have this cross-sectional area, so assuming na same cross-sectional area to, no? So how do we solve for the volume? Diba, volume is area times L. Okay? But yung L, so if we have velocity, so since meron tayong flow, let's say meron tayong velocity V, okay? So kung meron tayong velocity, how do we solve for the distance? There's a given time, then distance L from dynamics. So yung distance x is equal to velocity times time. So in this case, ito yung x natin. Okay. So going back dito sa discharge, so volume is area times L over time. Then yung L is velocity times time. Velocity times time. Then all over time. So we can cancel yung time and mata natin that discharge Q is equal to area times velocity. Yan. So yan yung mga formulas na kailangan nating tandaan and so mga basic na formula sa hydraulics. So now let's proceed with the classification of flow. Fluid flow can be classified as either uniform or non-uniform flow, can be steady or unsteady flow, and can be classified as laminar or turbulent flow. And meron din tayong continuous flow and of course, kabaliktaran is non-continuous. So sa uniform flow, so when do we say that a flow is uniform? So uniform flow is that the velocity at any point, okay? So at any point, no? So let's say meron tayong pipe dito. Okay. So let's say meron tayong point 1, 2, and 3. Okay. So for the uniform flow, velocity at any point is constant. Okay? So at any given time. Okay, so at any given time, kailangan para sila ng velocity. So paano mangyayari yun na para sila ng velocity? So sabi nga natin kanina, yung formula natin sa discharge Q, that is area times velocity. So velocity is Q over A. So alam natin na definitely point 1, 2, and 3 will have the same discharge Q. Okay? So para-paras lang yan ang discharge kasi kung ano yung pumasok dito, wala namang ibang pupuntahan niya kundi yung point 2 rin and yung point 3 and going out doon. Okay? So that is actually yung continuity equation. So Q1 is equal to Q2 is equal to Q3. Okay? So kung ano yung pumasok, kung ano yung dumaan dito, yun din yung lalapis na sa kabilang side. Okay? Or basically the summation of Q in must be equal to the summation of Q out. Again, that is yung continuity equation. So in this case, again, so alam natin na yung Q1 is equal to Q2 and same discharge at Q3. So paano magiging uniform yung flow? So dapat nga daw they have the same velocity. If this is constant, the discharge Q is constant, then area should also be constant. So if this is pipe, so dapat yung diameter should be constant then. If this is a circular pipe, no? Basically, yung A should be constant, yung cross-sectional area, for us to say that the flow is uniform. So kung yung flow is, let's say, yung pipe is, yan, nag-change ng diameter, just like in a nozzle. Okay? So mas malaki yung diameter dito sa, if we call this 0.1, as compared dito sa 0.2. So this will be a non-uniform flow. Okay? Kasi, titingnan natin doon sa, sabi natin, by continuity equation, Q1 must be equal to Q2. Okay? So, Q1 is equal to Q2. Discharge Q is area times velocity. So, area 1, velocity 1 is equal to area 2, velocity 2. Okay? So, in this figure, mas malaki yung area 1 sa area 2. So, solving for V2, so, diba, this will be area 1, velocity 1 over area 2. So, if area 1 is greater than area 2, so, eto, yung value na to will be greater than 1. Kasi nga, mas malaki yung A1 kaysa sa A2. So, if this is greater than 1, then velocity 2 will be greater than velocity 1. So, bibilis yung velocity natin dito sa point 2. Okay? So, therefore, in this kind of conduit, then we will have a non-uniform flow. So, dito naman tayo sa classification of fluid flow na steady flow. So, kailan natin masasabi na yung flow is steady? So, it is when the discharge Q is constant at any time. Okay? So, hindi nagbabago-bago yung discharge natin. So, medyo nakaka-confuse na siya dun sa uniform flow sa steady flow. So, yung uniform flow at any given time, let's say at time equals to 1. So, at very specific time na yon, so yung velocity natin at any point along the conduit is constant. While yung discharge Q naman, yung steady flow rather, is para sa steady flow is constant at any time na during the analysis ng flow. So dito pwedeng after 10 seconds magbago yung discharge mo, bumilis yung discharge mo, but still at that very specific time, okay, yung velocity natin doon sa mga points na yon are still pare-parehas pa rin. Okay? So yun yung difference ng steady flow and you say uniform flow. Okay, so about naman sa classification of flow na laminar or turbulent. So marami naman ng mga videos dito sa YouTube na nagde-demonstrate nung difference ng laminar and turbulent flow. But yung laminar flow is when yung, let's say ito yung mga particles tayo dito, no? So, marami tayong particles ng liquid or fluid. So yung particle na to, ang movement niya, yung movement ng bawat particles are parallel. Ayan. So, hindi siya nagko-cross. Kumbaga, smooth lang yung flow ng mga particles ng fluid. While dun sa turbulent, ito yung mga particles na analyze natin. So, magulo sila, no? Pwede siyang umikot ng ganyan. Ito naman, ayan. So, parang chaos talaga yung movement. Okay? Itong streamline. So, magulo siya. So, that's why pagka nasa aeroplano tayo, di ba? Pagka sinabing may turbulence, so umaalog, parang nalulubak yung airplane natin. It's because, yun nga, may bumabangga na baga na nababangga ng mga particles yung wing ng airplane. So, unlike sa kapag laminar lang, smooth lang, so yung streamline ng particle, yun, so ganyan lang siya. So hindi sila magulo. Yan. So, when do we say or how can we predict yung laminar or turbulent flow? So, commonly used is based on the Reynolds number. Reynolds number. So, may formula tayo dyan. No? So, later na yun. If yung Reynolds number is less than or equal to 2,000, so we can conclude na yung flow will be laminar. Okay? Then higher than that, it can still be laminar. It can still be laminar flow no kahit mas mataas dito. Kaya lang ano na siya, kumbaga hindi na siya stable. Kumbaga konting bumps lang or disturbance dun sa flow, then it will become turbulent agad. Okay, so those are the basics ng flow of fluid. So let's proceed with our examples. So problem number 1, water flows through a 3-inch diameter pipe at a velocity of 10 feet per second. So identify muna natin yung mga given. The diameter is 3 inches and velocity is 10 feet per second. So find so ano yung required? Okay. So volume flow rate in cubic feet per second. So discharge Q in cubic feet per second. Okay. And gallons per minute. Okay. And for letter B, weight flow rate, and letter C, mass flow rate. Okay. So since this is English units, so slugs per second, and no, this is pounds per second. And for the mass flow rate, so dito natin gagamitin yung slugs per second. Okay. So, yun sa formula natin kanina, that discharge Q is, na-derive natin kanina, no? Area times the velocity. So, we have the velocity, we have the diameter, so makukuha, dali lang natin makuha yung discharge Q. Okay? So, ang area is, so yung 3-inch natin, convert natin sa feet. So, 1 foot for every 12 inches. Okay, cancel yung unit. Yan. So, meron tayong 0.25 foot. Okay, so area is pi in terms of diameter is pi over 4. Diameter is 0.25 foot squared. Then the velocity is 10 feet per second. Okay? So, meron tayo ngayong feet square foot times foot. So, ang unit natin is cubic foot per second. Okay, so solve natin. So, 0.25 pi times 0.25 feet, then squared, then times 10 feet. Okay, so yung discharge Q is 0.491 cubic foot per second. Okay, so in terms of gallons per minute, so may conversion tayo na for every 1 cubic foot, this is equivalent sa 7.48 gallons. Okay? So kung hindi man natin to matandaan, no, tong conversion factor na to, yung 1 cubic foot, So, pwede natin itong i-convert sa cubic meter. Okay, so put dito sa denominator, no, para ma-cancel natin. So, meter naman sa taas. So, alam natin na for every 1 meter, this is 3.281 feet. Okay, then cube natin. So, ang volume natin ngayon is magiging ano na, a meter cube na tayo. Okay, and then to convert cubic meter to gallon, so pwede convert muna natin sa, so ika-cancel natin yung cubic meter. So dito naman sa taas is liter. For every 1,000 liter, so meron tayo 1 cubic meter. Okay, so ngayon naka-cancel ngayon to. Okay, so naka-liter tayo ngayon. And then liter to US gallon, so ito yung mas alam kong conversion. Mas common is, so liter sa denominator para mag-cancel, and gallon sa numerator. And for every 1 gallon, this is 3.785 liters. Okay? So itong conversion na to, nakita ko lang sa sinesyon sa internet. Marami naman tayo conversion dyan. Okay? So tingnan lang natin kung gaano kalaki yung discrepancy. So 1 times 1,000, ito yun. Okay, then 1 gallon, then divided by 3.281 cube times 3.785. Yan. So, ang makuha natin is 7.4802. So, this is gallon. Okay, so cancel na dito yung liter. Ayun, so ano naman? Kung titingnan natin sa internet, 7.480052. So, very minimal lang yung naging discrepancy, no? So, ganun lang, no? Kung hindi natin alam directly conversion from feet, cubic foot to gallon, so, gawa natin ng walk around. Kung yung mas alam natin na conversion unit. Okay? So, ito na lang yung gamitin ko. Kasi most like, baka makalimutan ko ito, no? So, ito na lang. Pero kasi yung dinerive ko. Okay? So, yung discharge Q in terms of gallons per minute. So, multiply natin ito ngayon ng, so, gusto natin makancel yung cubic foot, no? So, for every 1 cubic foot, that is, so, gallons sa numerator. Okay, 1 cubic foot is 7.4802 gallon. Okay. So, magka-cancel yung cubic foot. And then, meron tayong ano dito, per second lang to, no? So, gusto natin makancel yung seconds. So, nasa denominator to. So, kailangan natin sa numerator. Then, sa denominator ngayon yung minute. And for every 1 minute, we have 60 seconds. Okay? So, etong answer natin kanina. So, gamitin ko yung exact value, 0.4908. Then, conversion factor natin, 7.4802. Then, times 60. Ayan. So, discharge Q is also equal to 220.311 gallons per minute. Okay. So, para naman sa next question, weight flow rate and mass flow rate. Okay. So, for the weight flow rate, so yung formula nga natin dito is unit weight, okay, times the discharge Q. And the unit weight of water in English units, English system, is 62.4. This is pound per cubic foot. Then multiply by the discharge in cubic foot per second, 0.491. Okay, so we can cancel cubic foot. Yung makukuha natin is pound per second, which is again yung weight flow rate. Okay, so 62.4 times 0.491. 0.491. Okay, so we have 30.638 pounds per second. So what about the mass flow rate? So ano ba ang density? So kung ito yung mass kabisado natin, yung unit weight, alam din naman natin that unit weight is equal to the density times gravity, and solving for the density, that is unit weight divided by the gravitational acceleration. So yung G is 32.2 feet per second squared. Okay? So para maging output nito is slugs per volume. Okay? Slug per cubic foot. So solving for the mass flow rate, again, yung formula natin is the density times the discharge Q. Pero yung density is the unit weight na 62.4 pound per cubic foot, then divided by 32.2 feet per second squared. Then this will be equal multiplied by 0.491 cubic foot per second. So we can cancel this. Paano makakancel ngayon itong feet per second square dito sa pound? So this is similar lang din naman sa yung 1 Newton is 1 kilogram, okay, times 9.81 meter per second squared. So yung unit natin na Newton is kilogram meter per second squared. So dito ganun din, no? This is force, yung pound natin is a force. Then if you divide that by the gravitational acceleration in feet per second squared, so ang magiging unit nito ngayon, so this will be in slugs. So let's multiply this. 62.4, divide natin ang gravity, 32.2. Okay, so that's density na, no? Unit weight over gravitational acceleration is density. Then times the discharge 0.491. Okay, and for the mass flow rate, so we have 0.952 slugs per second. Okay, so let's now proceed dito sa next problem natin, yung benzene. Okay, so benzene flows through a 100 millimeter diameter pipe at a mean velocity of 3 meters per second. Find the volume flow rate in meter cube per second and liter per minute, then weight flow rate and the mass flow rate. So given the density of benzene to be equal to 881 kilogram per cubic meter. So sinabi dito, no, yung average mean or average velocity. Bakit average or mean velocity ang given? So kung meron tayong pipe, okay, yan. So yung velocity gradient natin is hindi siya constant, hindi para-paras yung velocity ng bawat particle natin dito, no? Okay? So for a laminar flow, this is parabolic. Parang ganyan siya. So maximum velocity, sabihin kung halimbawa, pantay-pantay muna dito yung mga particles natin. So at a certain time, yung nasa gitna natin will travel this distance. So siya yung pinakamabilis. Okay? Yung dito naman mas medyo hindi ganun kalayo yung narating niya. Dito mas malapit ay narating niya. So mas mabagal siya. And velocity natin at the wall is 0. So this is yung flow ng real fluid. So alam naman natin yung sa fluid mechanics, meron tayong real fluid and meron tayong ideal. Okay? So ganun din. So meron tayong ideal flow And meron tayong real flow. So yung ideal flow is nine-neglect natin yung friction na dito sa wall. Friction between the wall and the liquid. Pero in actual, so meron tayong friction dyan. So that's why yung velocity, yung mga particle natin na naka-attach dun sa wall has a velocity of 0. Okay? So kaya ang ginagamit natin sa solving karamihan is the mean velocity. So yung average lang nitong lahat. Okay? So yan. So again, the velocity is 3 meter per second. Then ang hinahanap is flow rate in cubic meter per second and liter per second. Then for B, so weight flow rate and mass flow rate. Okay? So madali lang naman to, no? So meron tayong given din na diameter na 100 millimeters or 0.1 meter. Okay, so discharge Q is equal to area times velocity, circular pipe ulit, pi over 4, then diameter is 0.1 meter squared, multiplied by the velocity, 3 meter per second. So meter squared times meter is meter cube, then per second. Pi over 4 times 0.1 squared and times 3. Okay, so we have 0.02356 cubic meter per second. Okay. So in terms of liters, so 'di ba multiply lang naman natin 'to ng gusto natin makancel yung cubic meter. Kailangan natin sa denominator. So yung liter should be on the numerator. So for every 1 cubic meter, 1,000 liters. Okay? So we can cancel cubic meter here. Then multiply lang naman ng 1,000. So we have this is ano pala, no? Liter per minute. Mali pa na to. Liter per minute. Okay? So kailangan din natin i-convert yung second to minute. So gusto natin makancel yung second. Dito yung minute sa denominator, and for every 1 minute, we have 60 seconds. Okay? So yung answer natin will be multiplied by 1,000 and 60 seconds. Ayan. So we have 1,413.7 liters per minute. Okay. Then for the weight flow rate and mass flow rate, okay, so again, given yung density. For the weight flow rate, so this is unit weight times the discharge Q, and the unit weight is, yan natin, unit weight is the density times the gravity. Okay, so given the density of 881 kilogram per cubic meter, okay, multiply natin ng gravity, 9.81 meter per second squared. Okay, then the discharge Q of 0.02356 meter cube per second. So yung weight flow rate natin will be in Newton kasi kilogram meter per second squared. So that's Newton. Okay, so pwede naman natin idiretso ang hinahanap is in kilonewton. So convert na lang natin. So kilonewton to Newton. For every 1 kilonewton, we have 1,000 Newton. Okay? So 881 times 9.81 times 0.02356. Okay? And baliktad pala, sorry. Yan. So naka-Newton tayo dito, so gusto natin i-cancel yung Newton, so dapat nasa denominator. So sa numerator yung kilonewton. So 1 kilonewton is 1,000 Newton. Then this should be divided by 1,000. So we have 0.2036 kilonewton per second. Okay? While for the mass flow rate, dito ko na lang ilagay. So this is given in density 881 kilograms per meter cube. Okay? Then times the velocity, discharge Q, 0.02356. Unit natin dito is cubic meter per second. Okay? So we can cancel this. So 881 times 0.02356. So we have 20.756 kilograms per second. Okay. So let's proceed dito sa next problem. So by the way, this problem is from Frank M. White. Fluid Mechanics by Frank M. White. So water at 20 degrees Celsius flows steadily through a closed tank. So at section 1, given the diameter, sulat natin mga given dito. Diameter is 6 cm or 0.06 meter. Okay. And the volume flow rate is in discharge Q. So this is 100 cubic meter per hour. Okay. So at section 2, diameter is 5 cm or 0.05 meter. Okay. And the average velocity is 8 meter per second. Okay. So velocity naman yung given. So sa 3, so ang given na sa 3 is its diameter, 4 cm or 0.04 meter. Okay? So in this figure, sa mata natin na yung 1 is inflow, yung in, then this one is outflow. Okay? While yung 3, so it can be inflow or outflow na hindi natin alam. Okay, so paano natin ma-determine? So the general rule lang naman is by continuity equation. Okay, so the summation of inflow must be equal to the summation of outflow. Okay, so meron tayong isang sure na in, isang sure na outflow. So let's compare yung dalawa. So meron na tayo dito, no? So convert natin to sa cubic meter per second. So multiply lang, convert lang natin to. So hour. So for every 1 hour, we have 3,600 seconds. Okay? So 100 divided by 3,600. Yan. So we have 0. Ano ito na lang? 1/36 cubic meter per second. So para mas accurate yung makukuha natin. Okay? But roughly this is 0.02778 cubic meter per second. Okay, so given the velocity, we can solve for Q sub 2. Q sub 2 is equal to area times velocity, no? So naka-meter kasi ang unit natin dito. So gawin din natin tong cubic meter. Pi over 4, area natin is pi over 4 times diameter squared. 0.05 meter squared. And the velocity is 8 meters per second. So Q2 is equal to pi over 4 times 0.05 squared, then times 8. And so this is 0.01571 cubic meter per second. So, if i-compare natin, Q1 is greater than Q2. Okay? So, mas malaki yung inflow kaysa sa outflow ng 0.2. So, meaning, kailangan pa natin ng additional discharge para ma-satisfy natin yung summation ng inflow and outflow. So, ngayon, we can say that Q1 is equal to, so dalawa yung magiging output natin ngayon. So, Q sub 2 plus Q sub 3. So, ito ngayon yung summation ng outflow. Okay? So, Q1 is 0.02778. Lagyan ko na lang kung more significant figures. Then, equal to 0.01571 cubic meter per second. Same lang to. Then, plus Q sub 3. Okay? So, we can now solve for Q sub 3. So, yung difference nilang dalawa. So, 0.02778. So, ito yung gamitin ko. Then, minus natin ngayon to, no? 0.0157. So, this is 0.01207. Okay? This is in cubic meter per second. So, ano nga ba yung nahanap? Q3 in cubic meter per hour. Okay? So, in terms of volume per hour, so multiply lang natin to ng 3,600 second for every 1 hour. So, cancel lang to. So, this one will be multiplied by 3,600. So, we have 43.451 cubic meter per hour. Okay. So, what about the average velocity in meters per second? So, from the equation na Q is equals to AV and velocity is Q over A. So, yung discharge Q, yung meter per second, no, cubic meter per second, 0.01207 cubic meter per second, then divided by area na pi over 4 times diameter 4 cm or 0.04 meter. So, makikita natin dito, meron tayong, squared pala to, no? So, pi over 4d squared. Sumata natin na meter cube sa numerator, then meter square sa denominator. So, we can cancel yung dalawa dito, no? So, magiging meter na lang. Meter per second. So, meter cube over meter squared is meter. Okay? So, yung discharge Q, yun. Then, divided by pi over 4. Then, times diameter squared, 0.04 squared. So, velocity 3 is equal to 12.5 meter per second. Okay. So, let's proceed na kagad sa last example natin for this video. So, another water again flows at 20 degrees Celsius. So, flows steadily at 40 kilograms per second through the nozzle in the figure below. So, wala pa pala yung nozzle. So, papayin ko lang. Yan. So, ito yung 1. And this is yung 2. Okay. If D1 is diameter is 18 cm or 0.18 meter. Then 2, diameter 2 is 5 centimeters or 0.05 meter. So compute the average velocity in meter per second in section 1 and B section 2. Okay, so velocity. So we need to solve first for the discharge Q. So ang given kasi is mass flow rate. Okay? And again, mass flow rate is equal to the density, okay, times the discharge Q. So yung density ng water at 20 degrees Celsius is 998 kilograms per cubic meter. Okay? So solving for discharge Q, this is mass flow rate natin, 40 kilograms per second, then divided by the density, 998 kilograms per cubic meter. So we can cancel yung kilogram, then yung meter cube is mapupunta na dun sa taas. Okay? So we will have cubic meter per second. Okay. So yung Q is 40 divided by 998. So we have 0.04008 cubic meter per second. So solving for the velocity at section 1 and section 2. So again, from Q is equal to area times velocity. So solving for the velocity 1 is, so since by continuity equation and wala namang ibang pupuntahan yung liquid natin, yung water natin dito. So again, summation ng inflow must be equal to the summation of outflow. So dalawa lang naman sila. So Q1 is equal to Q sub 2. Okay? So velocity 1 is Q sub 1 0.04008 cubic meter per second divided by the cross-sectional area. So pwedeng in terms of diameter or pwede naman in terms of radius. So ang radius natin is 0.09 meter. Okay? Then squared. Then velocity 1 is equal to, so solve natin mamaya. Velocity 2 is equal to the same discharge. Q1 is equal to Q2, 0.04008 cubic meter per second. Then divided by pi, then 0.05 meter. Radius is 0.025 meter, then squared. Then solve natin. 0.04008 then divided by pi times 0.09 squared. Okay? While sa 0.2 to 0.025 yung ating radius. Yan. So velocity at 0.1 is 1.575 meter per second. Okay? So naman natin maka-cancel to. So again, meter squared, then may meter cube. Yan. So pwede natin i-cancel to, magiging meter na lang. Okay, so ganun din dito sa V2. Then V2 is equal to 20.413 meter per second. Okay, so that's it for the fundamental of flow sa subject natin na hydraulics. So, ayun lang, medyo matagal lang magawa ng mga videos, but I'll try to keep up this term para meron kayong additional resources or lecture other than those in your modules. Okay, so again, salamat sa panonood and see you on my next video.